Hello ladies and gentlemen, coming to you once again, not quite live from One Take Studios, where we are talking about solving systems of equations again today with a third method. So we've already talked about graphing, we've talked about substitution, and today we're going to solve by elimination. This is also known as solving by combination, so perhaps you've heard that as well. Again, our focus is going to stick to two variables with two equations. If we have two variables that we don't know, we can't do it with one equation, but if there's two, we can actually make this happen. Could you use this with larger systems, more variables? Absolutely you could. I don't think I would wish that on my worst enemy, but it is possible. So there we go. So ladies and gentlemen, whatever shall we do? Well, okay, so here's the plan. This is our game plan right here. We're going to add, or technically subtract, equations together, so combining equations, in such a way that one variable drops out, hence the name elimination. We're trying to eliminate one of our variables. So this right here, know it, love it, this is the entire game plan. And if we can make this happen, then we can solve. Again, we can't solve for two equations at one time, so two variables at one time. But if one goes away, we are all of a sudden free to solve. So I've got 4 examples for you again today, and we're going to start with this guy right here. Alright, so again, this is a system of equations. These equations go together, and it's not that we're solving one or the other, but we're looking for the one point that is a solution for both. The one point that works in both equations at one time. Again, if we were to graph this, that's where they would intersect. But we're not graphing today, so there we go. Okay, so this one is obviously kind of a nice one to get us started. If we're going to eliminate, think about right now, if I were to just add these equations together. Note something very nice. They are both in standard form. X's are lined up with X's, Y's are lined up with Y's, and the things without variables, the constants, those are also lined up with each other. So all of our like terms are right over top of each other. Why is this useful? Well, watch what's about to happen. Alright, this is going to be my giant addition line, and we're going to add the two equations together. So 2x plus 6x is 8x. Plus 3y minus 3y. One is positive, one is negative. When I add them together, one of them, the y's, are going to drop out entirely. They're just going to be gone, and that's going to make us really, really happy. We're going to keep the equals sign now that these guys are gone, and 11 plus 21 is going to be 32. All of us in our lives are much happier because 8x equals 32, that's something that I can handle. That's something I can solve. Getting my x by itself, divide by 8, undoing the multiplying by 8, goes away. There's my x, there's my equal sign, and 32 divided by 8 is 4. Should I celebrate now? No, because remember that we are still finding an ordered pair. We're looking for a point. So having x is not enough. Alright, that's not going to cut it. So here's the slightly messy part. Again, we're going to take the number that we know, and we're going to go back and plug it in place of x in one of these equations. When we're working with substitution, it's often a little bit easier to find one that's nice to plug into. This is not going to be as nice, but I promise you that we will survive. So just because, why not, I'm going to take this first equation. I'm going to rewrite it. So 2x plus 3y equals 11. And I'm going to say, you know what? I now know that x is 4, so I'm going to take, right there, the 4 and put it in place of the x. So instead of writing 2 times x, I'm now going to write 2 times 4. Still plus 3y, still equals 11. That means I actually have 8 plus 3y equals 11, and I can solve for y to get the other half of my ordered pair. Minus 8, undoing everything around the y, undoing things in reverse order of operations, so getting rid of that first, that's going to be 3y equals 3. Oh, that's not that bad. And then dividing by 3, there we go, y equals 1. So again, 4 is not my answer, 1 is not my answer, but the two of these together make an ordered pair, and that ordered pair is 4, 1. Again, if I graph these two lines, that's going to be the point where the lines cross, but if I plug this point into both of these equations, it makes both of them true. So that is my solution. Alright, so that's best case scenario. Let's look at what was really awesome about that one. I had a plus 3y and a minus 3y. It was all set up, ready to go. Those were going to drop out right off the bat. Is it always that nice? Of course not. Life is messy. So, let's check out another one, shall we? Let's do this and block out part of my screen so we can deal with one thing at a time, shall we? Alright, so here's our next example, and these equations are x plus y equals 3 and x minus 4y equals negative 22. If I just start off the way I started the last one, notice again, very nicely, all of my like terms, everything is lined up. X plus x would be 2x, those didn't go away. Positive 1y minus 4y, that'd be negative 3y, those wouldn't go away. If I leave this as is and I just try to combine these, it's not going to be as happy as it was last time. So what can we do to fix this? What can we do to make it better? Well, again, two things here. Both were 3's. One was positive, one was negative. If I look at my current system of equations, this is a 1, this is a 1. Both x's have the same coefficient, the same number in front of them. It's just that we don't have one positive and one negative. Some people will do this by subtraction, and if you are a beginner, I don't recommend that, because it is so easy for you to lose track of a negative sign and therefore get confused. So here's what I'm going to recommend. Stick with addition, and let's just create a situation where I do have opposites. What if I took my entire second equation and said, I'm going to multiply this whole equation all the way across. I'm going to multiply it by negative 1. Negative 1. Well, okay, so what's going to happen? At the moment, I'm just going to copy my first equation over again. I'm going to leave it as x plus y equals 3. All right, I didn't change the first equation at all. But the second equation, I'm going to do negative 1 times my 1x. That's going to give me negative 1x. Ooh, fancy. I also have to do the negative 1 times the negative 4y. Negative 1 times negative 4 is positive 4y. And then all the way through, negative 1 times negative 22 is a positive 22. All right, you have to distribute. You have to do the number out front, the negative 1, times every single last piece of your equation all the way across. If you miss one, you're going to end up being off somehow. All right? Now, why do I like this? Because now I'm all set up and I can do my addition. There's my adding line to add these together. I now have a positive 1x and a negative 1x, which means I have opposites, which means these guys are going to drop out. And yay, I am happy because now I have a variable that's gone away. Now, on my first example, I got rid of the y's, and on my second example, I got rid of the x's. Again, it doesn't matter which one you get rid of as long as you get rid of one. I also need to do the y plus the 4y. 1y plus 4y is 5y's altogether, and 3 plus 22 is 25. Hey, solve for y. Undo the multiplication. There we go, and therefore y equals 5. Yay, we're done! No, we're not. No, we're not. But hey, if I have to pick one of these to plug back into, I'm going to pick the first one just because it's got a lot less numbers, and I think it'll be nice to work with. So I'm going to take my first equation here, x plus y equals 3. I'm going to say, I now know that the y equals 5. So I'm going to take my 5 and plug it in right there in place of the y. So this becomes x plus 5 equals 3. And now I can solve. I'm going to squish a little bit here. We're going to do minus 5 on the left, minus 5 on the right. Those are going to drop out. And what's going to happen? I will be left with my x. And I will have 3 minus 5 is negative 2. There's my x. There's my y. I have my pair. That is it. Negative 2 is the x value and 5 is the y value. That is my solution right there. So honestly, that can be the most challenging part, is making sure that you've got one of your variables all set up to drop out. Same number in front of the x or the y, and then one positive, one negative. That way when you add them, poof, one of them goes away. All right, so here's another one. And I'm a little squishy for space. I'm sorry, I'm going to do this. There we go. Just to separate the page a little bit better so we can see first example separated from second example. This one is even worse than the last one. Or is it? Maybe it's not so bad. I mean, okay, so right now if I add 7x and 8x, there's no way that's going away. I have a 3, a negative 3y, and a positive 1y. So if I'm looking for a bright side, that one's negative, that one's positive. I mean, I do want to have opposites so they drop out. I just really wish there was a 3 sitting here. Can't I make that happen? I mean, last time I just chose to multiply by -1 so I could make my positive and my negative. What if I choose to multiply by 3? That could have benefits. So again, multiplying everything by 3. Multiply the first term by 3, multiply the second term by 3, and why not? Let's multiply the third term by 3. So that the first equation is still going to stay 7x minus 3y equals 10. But now check this out. All right, so 3 times 8, that's 24x. 3 times y, that's plus 3y. Happiness and joy. Look what's going to happen. 3 times 38. Oh my gosh, those are such large numbers. I'm never going to survive. Actually, yes, you will. Suck it up, grab the calculator. Oh, look. 3 times 38 is 114. There we go. So we will put 114 right there. And while that seems terrible, I bet you it works out pretty well because we're just learning this. So I bet you it works out. Okay, so what's going to come next? Oh, now we're all set up. We have what we need, and we can add them up. Add the first line to the second line. 7x plus 24x, that doesn't go away, but that's going to be 31x, okay. Minus 3y plus 3y, they are opposites, gone. Happiness and joy. 10 plus 114 is 124. Last step, get x by itself, undo the multiplication with division. You know what? I bet you that goes in nicely. X equals, what does x equal? 4. That goes in really nicely. So x is 4, but we're not done yet. Where are we going to plug this one in? You know what? Honestly, I might go back to this guy again, because the y is sort of ish by itself. You can't really go wrong. You can plug that number back into any of these equations here. I'm just trying to pick the one that makes my life the easiest. So if I plug into this one right here, so I'm going to take my 8x plus y equals 38. All right, so that's one of my original equations. I'm going to say, I now know that x is 4. So I'm going to go here, dun, 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 and take out the x and put a 4 in its place. So this now is 8 times 4 plus y equals 38. Which means that's going to be 4 times 8 is 32, plus y equals 38. I got some messy handwriting today, goodness gracious. Undo the plus, minus 32, gone. There's the y by itself, and that's going to be 6. Now I can rejoice. My x is 4, my y is 6, I have a point. That point is my solution. It makes both equations true. Ta-da! Alright, so now, you've sampled everything. What if we make the worst case scenario? Think we'll survive? I bet we could survive. Let's see if we can survive. Alright, so we've got a couple examples to look at of what we've done so far. Check this one out. Okay, so what do we like and what do we not like? The x's are lined up, the y's are lined up, and the constant values are lined up, so that's good. -2 and 5, that's not going to drop out. 3 and 4, that's not going to drop out. Ish. I mean, here for the first one in this example, for this side, we had 1 and 1, but that's a 2 and that's a 5, that's a 3, that's a 4, so it's not as nice as that one. And here, I had a positive negative. I mean, I just had to multiply by 3, and I could make that happen, but really? What do I multiply 5 by to make it into a 2? Or what do I multiply 2 by to make it into a 5? That's not going to work. What do I multiply 4 by to turn it into a 3? That's not happening either. What do I multiply 3 by to turn it into a 4? Yeah. Alright, so it is possible, ladies and gentlemen, that you have to alter both equations to make this happen. I'm going to focus on the x's just because I do have one negative and one positive, and I like the fact that I've got opposites for dropping these out. So the question is, how do I make the 5 and the 2 compatible? How do I make it so I have the same number so that something actually drops out? Well, 5 times 2 is 10, yes? So what if I multiplied the top equation by 5, and I multiplied the bottom equation by 2? Of course, if I was going to do that, I'd have to multiply all 3 terms all the way across. Distribute, distribute, distribute. We're just going to distribute the snot out of this thing. Here we go. What's that going to give us? I've got the full page to work here, so I'm actually going to write it here. So I'm going to do 5 times the negative 2x is negative 10x. 5 times 3y, that's going to be plus 15y. And then 5 times 53, oh goodness, 5 times 53. Whatever shall I do? Oh, that's right. 5 times 53. 5 times 53, friendly calculator says 265. thank you to the friendly calculator, equals 265. Could I do that in my head? Yes. My brain hurts right now. If I do 2 times 5x, what's going to happen to my second equation? That's going to give me 10x. Look, 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 look. Because I multiplied this one by 5 and this one by 2, I created a negative 10 here, and I created a positive 10 here. How did I know to do that? I just said, hey, what's 5 times 2? It's 10. What if I make them 10s? There's no set of rules here specifically that I have to follow. It's possible that I could multiply the equations by 3 and 4 and I could make the y's drop out instead. You have some flexibility here, and for some people that is the worst thing ever because it just messes with their brains. 2 times 4y, that's going to be plus 8y, and 2 times negative 6 is going to be negative 12. Now, my friends, now I can add my equations together. There we go. And so dropping out, goodbye, 15 plus 8, that should be 23y, equals 265 minus 12. All right, I think I can pull this off. That's going to be a 2. And 65 minus 12 is 55 minus 2 is 53. Oh, let's hope that's right. That could be promising though, right? 253 divided by 23. 253. 253 divided by 23. Oh, whew, that works out nicely. You can't see it. There we go. 253 divided by 23 is 11. Okay, that makes us happy. Dividing by 23, dividing by 23, undoing the multiplication. There's my y by itself, and that just plain old equals 11. Is it possible to end up with decimals and fractions for this? Yeah, absolutely it is. It gets messy. But again, we're just learning this, and so we're going to deal with something a little bit nicer for the time being. Okay. Ah, crud. We're not done. We're not done. Pick an equation to plug back into. Honestly, I don't think that there's a better choice or a worse choice here, so I'm just going to pick the first one because it's the first one. So I'm taking negative 2x plus 3y equals 53. I'm just recopying that first equation, but I'm going to say I now know that y is 11, so right over there. I'm going to take out the y and put in the 11. So minus 2x plus 3 times 11 instead of 3 times y equals 53. And now clean up on aisle 4. What can we do with this? That's still going to be in minus 2x for the time being. 3 times 11 is 33 equals 53. There we go. And again, undoing everything around the x. So undo the addition first. Minus 33. Both sides of the equation. Poof, gone. My minus 2x is still there. My equal sign is still there. 53 minus 33 is 20. Oh, that's kind of nice. And again, undo the multiplication by dividing negative 2. Dividing negative 2. Gone. X equals negative 10. There we go. I have an x, I have a y, I have my point. So negative 10, 11 is my answer. There we go. So essentially, this is like a worst case scenario sort of thing. Maybe you like this, maybe you don't. You should probably get used to it a little bit just because having options makes your life easier, because sometimes it's really, really nice to be able to use system solving by elimination. All right? Sometimes substitution works better, sometimes graphing works better. But having the flexibility in your mind to kind of go between your 3 options is ideal. A real quick mention here, what were to happen if I were to start adding my equations together and both the x's and the y's dropped out? What if they were all gone? Well, the last video had an example of something where that happened. It depends on what you're left with. If all my variables went away and I had 0 equals 0, I would say, well, that's true, 0 does equal 0, so I have infinitely many solutions. What if I'm left with something like 0 equals 24? 0 doesn't equal 24. That would be no solution. All right, so these things can happen. I decided to focus on examples that did have proper solutions today, and good luck. Don't give up. Keep looking at your models as you try to figure it out, okay? All right, you got this.